Okay, hello. In this short little video, I just want to walk you through the steps that are required to write data out to a text file and just talk a little bit about paths, file paths, and how they can be used to direct where you would like to output your text file. There's a default location if you do not provide a path to the file name that you'd like to write to. So we'll explore that, and I'll also show you how you can capture input and then use that as a means to determine where you'd like to output your text file. So the first thing we need to keep in mind here is that when we've been writing our programs to this point, we've been just using classes and objects that are available in basically like the standard system namespace. And if we look at the top of the program here, you can see this first line says using system. And what you can do for now is just think of this namespace as like a big catalog or a library. And inside this library are lots of different objects and classes that are available to us by default to create our programs. So for example, when we see console, you'll notice that it's prefixed here with this system dot console. So in the same way that we have been using things like console dot write line, the console itself is something that is accessible from this system namespace. So we don't have to type in system dot console every time we use it, because we've specified here that we want to be using everything that's available in this system namespace. So anything that's in there, we could just straight away type in here. Now, when it comes to writing output to a text file, we need to have access to a class that's not available in the system namespace. Okay, so namely here we're talking about the StreamWriter, and the StreamWriter class is in a sub namespace, or the system.io namespace. So in order to have access to the StreamWriter, we have to indicate to the compiler that, hey, we want to link in this class from another namespace in this program. So there are a couple of ways to go about doing that. I'm just going to get rid of the console write line for now. If you're keen to it, you can just at the very top of your program type in using space system.io to indicate that we want to use that. But the IDE here, the editor, is pretty smart. If you just start typing in a class that's available in another namespace that it knows about, it'll just do the automatic import of that namespace for you. So if we just start typing in here StreamWriter, you'll see that it indicates here that StreamWriter is in system.io. And if we just kind of complete this, you'll notice that it automatically inserts the using system.io namespace line up here at the top. So we could have typed that in ourselves, but Visual Studio is pretty smart. So when we start typing it in here, it automatically inserts that line for us. So don't overlook that, okay? I know if you're getting comfortable just typing things straight away, it's easy to forget that anything is happening up here, but to know that it is, okay? And so we don't have to type it in explicitly, but it does need to get there somehow. Okay, so that's out of the way. Now, when it comes to writing output to a file, there are 3 steps that need to take place. One of them is we need to open the file or have some access to a stream to write to the file. We then need to write our data to the file, which could be a single output statement, or we could repeatedly output data in a loop. It's up to you. And then the third step is to close the output stream. So we'll just do one file output here by default to the default location, and then we'll include a prompt so that we can ask the user where they would like to output the file, and you can see how both of those options work. So to create a new StreamWriter, we need to give it a name. I'm just going to call it writer, and we need to assign it a new StreamWriter object. Okay, so this right now just says we have a variable called writer that can point to an object that's a StreamWriter type, but we haven't actually created anything yet. So when we're creating these new objects, we use the keyword new. So we want to create something that's new, and the object that we want to create is a new StreamWriter, right? And again, here you can see in the description, this implements a text writer for writing characters to a stream in a particular encoding. Okay, so we're not going to worry too much about the encoding, but the important thing here is that we are writing text. So this is perfect. It's a text writer. That's what we want. It takes care of opening the underlying output stream. We don't have to worry about that. It makes output to a file from C# really easy. So we want to create a new StreamWriter. And then as an argument to this, what we call the constructor, the function that's going to build this new StreamWriter object, we need to pass in a path to or the file name that we'd like to open. Okay, now the nice thing about the StreamWriter as well is that so long as you have the permissions, if the file doesn't already exist, it will be created for you. So we don't have to worry too much about that either. So I'm just going to create a file here. I'm going to call it test.txt, right? It's a short file extension for a text file. And that's going to open a stream to a file called test.txt. If it doesn't exist, it's going to create it. And it's going to create that because we haven't specified a path, we haven't expressed here a specific location for where that file should be. It's going to create it in the same folder that the program executes from. Okay, now we haven't looked at kind of the details of what happens when a program is compiled, but we'll see that shortly. Okay, I'll show you exactly where that file is going to end up, at least on a Windows system. I may do another video on a Mac to show you where to find it there. It's a little bit different the way that file system paths work between Windows and Mac. So now, once we've created this new StreamWriter, we could just go ahead and start writing data to it. So we can access our writer. And again, it's this output, the StreamWriter, is very similar to what we've already been using for our console output. So if you go to writer and press the dot operator, you'll see you have the familiar methods of write and write line. So, and you don't have to think of or learn any new ways to output data. It's exactly the same way that you would output data to the console, only we're directing the output instead to a file. So if you do a write statement to the file, it will write but keep the cursor on the same line. If you do a write line, it's going to write an entire line to the file, including ending line character sequence, so that you end up with a new line below what you've just written to the file. So let's just do a full out write line statement here first. And we can just do something simple like hello. This is from this is to a file. Okay. And so what that's going to do is it's going to write this character stream out to our file that's indicated here in the constructor that we use to build the StreamWriter. So this string of characters will get written to this particular file. And if that's all we wanted to do, the final step here is to simply close our writer. Okay, and that's important. That releases the file and resources back to the operating system so that the file can be used elsewhere. And that's it. As far as writing to a file goes, this is really what needs to be present somewhere in your program. Again, this particular statement here, we could put this in a loop. We could output numbers 1 through 10, repeatedly. It doesn't matter. I just have one statement here, but you already know about loops. If we wrap this up in some kind of a loop structure, we could repeatedly write lines out to the file. So I'll leave that for you to explore. Now that we've done this, let's execute this program and we'll see where our output file ends up. Okay. There we go. It's taking a second. So it executes. We don't see anything to the screen. We haven't done any console outputting or inputting, so it just runs the program and ends. So we can exit from there. And now you're going to be left wondering, okay, well, where's the file? I don't see it over here in my Solution Explorer, so it must not be available. Well, if you navigate to where your project directory is, so here's my Lesson04 file output folder, right? This is my solution and project directory. Here's the program CS file. There are a couple of folders here, and the first one is the bin folder, right? And this is like your binaries, the assets that are created from the compilation process or the build process for your program. So your program actually executes from within this directory. So if you go inside the bin folder, you'll see there's a debug folder, And then there's, in this case, a Net Core App 3.1 folder. And finally, in here, we can see all the outputs for our program. And here is our test.txt file. You'll notice the exe, the executable, this is the application. This is where it exists. So when we're debugging our programs, everything is being executed from this file path. So if I click up in here, you can see it. This is the default file path that'll be used in this case for this program. Okay, now if I want it to be somewhere else, then we need to provide a full path to where we want this file to go in here. And so what I'll do is we'll add a prompt so we can do that, but it's important to know by default, it's just going to output it to wherever the file executes from. So you'll have to find that exe. That's where you'll locate the test.txt file in this case. And if we open that up with like Notepad, you can see here's our line. It's been written out, and it was written as a write line. So I would expect there to be a blank line here underneath, and we can see that there is. So we wrote the line, cursor dropped down, and then we closed the file. So there's no more output to be had. Now, if you run the program again, it will just overwrite the contents of this file. If you'd like it to append to the file and output more statements after the last one, that's possible too, but I'll leave that as an exercise for you to explore. See if you can't modify this short little program so that instead of overwriting a file, it appends a line to the file at the end. I'm just going to delete this test.txt file for now. I don't need that in there. And let's navigate up to our project directory again. So here, if this is where I would like my output to go, we can prompt the user and ask where would we like the output, and then we can specify the full path to where we'd like it to go. So in this example, I want it to go into my project directory. So let's just add a quick here. We'll add a prompt. Yeah, I guess it doesn't really matter. Oops. Let's create a string for the path. I won't worry about program titles. This is just for demonstration purposes. So let's prompt the user for a location. So console write. And here we're going to ask enter a file name, include, we'll say here full path. Okay, and then we can get the path. We'll read that in. And so here where I've created my StreamWriter, I don't want to do that at this point in time. So let's just declare the StreamWriter. Again, we can declare StreamWriters like any other variable. So we're saying, hey, I've got a variable called path. It can hold strings. And I've got a variable called writer. It can hold or access a StreamWriter. So once we've prompted for it, asked for the path, now we can go ahead and we can open that stream. We can't do it until after we've prompted the user. So in here now, instead of test.txt, we're going to throw the path variable. So whatever the user entered when we prompted them, we're going to use that as the target for what we'd like to use to open the StreamWriter for. And then we'll do the same thing. We'll write this statement out and we'll close it. So let's save this and we can execute this program. And now we're going to get, we're going to see a pause in the console. We're going to be prompted and we can enter in our path. Okay, so it's going to wait here. What's our full path? I'm going to navigate to my file explorer. I'm going to click here in the address bar and I'm going to Control-C, copy the path. And you can paste into your command prompt by just right-clicking. It should just paste the value right in there. Notice Windows paths use backslashes. That's important. We'll talk about why in a minute. And this is a directory, so this isn't going to work. If you just enter that, your program's going to crash because it couldn't open a file called Lesson04 file output. So I'll put in a slash here and we'll create our test.txt at this location. So here's the full path starting at the root, which is in my case the C drive, and this is where I'd like that output stream to write to. So we hit enter, it does its thing, it completes, and now if we go back to our project directory, we can see our test.txt file. You can also see it here in the Solution Explorer. Okay, so a little bit about paths. It's important. If you wanted to use relative paths, you could, but again, it's probably not a great idea given that by default right now things are in the debug folder. It would probably be best to prompt the user in cases where you're giving the user an option to select a location for a file. Ask the user to enter it in, and then go from there. If it's something like program settings or something by default that you do want to store right where the program is being run from, then it's fine. Then you could use just a file name, and you're never going to ask the user for input because it's a file name that you specified. Then you don't have to worry about pathing and things like that. But in cases where you want to give the user the option to select, just prompt for a location and require that they include the full path, and away you go. Okay, that's pretty much it. There's one final thing that I'll show you here before we end this video, and that again has to do with the file paths. What we'll do is I'll just put a breakpoint. Oops. Oh, there we go. On this line here where we're doing our StreamWriter, and I just want to show you what the value of that path looks like inside the program, because again, the backslash is a special character, and in order to represent a backslash in your path, you have to escape the path. So let's run this. There's a couple of ways to do that. In the text readings for the course, escape sequences and also special pathing strings are shown, so you could see a little bit more information about it there. So let's do the same thing. I'm going to say here it's test.txt and hit enter. So now we'll break in the debugger and we can see what has been entered. And you'll notice here the value that's stored in that path variable is a string, but each of the backslashes is escaped. So it's not a single backslash, it's two. And so that's the escape sequence that's being stored here. So it's escape, the next special character, and use its literal value, which is itself a slash. Okay, because if you had /s, that may have a special meaning and you wouldn't actually get it as a file path. So just be aware that backslashes need to be escaped if you're going to use them in your code. Let's just stop this for the moment. And then for the moment here, let's assume that we had this value ahead of time. If we wanted to use it as a literal string value, so instead of prompting the user like we have at the moment, you'll notice that it's complaining already here just by assigning this value to the variable path. Let's get rid of this. Okay, and it's hey, like this, you can't do this. It's an unrecognized escape sequence. It doesn't know what \U is. So again, what you would have to do is escape those backslashes, and if you do that, you'll notice the red squiggly line goes away. But another way to do that is to create an escape string by prefixing the string literal, not with a $, which is for a string interpolation, but with an @ symbol. Okay, so the @ symbol in front of your string indicates that you don't want to escape anything, essentially. And now we don't have to worry about escape sequences. We can just use the single slash, and it reads the way that we would expect. So if you ever see the @ symbol at the beginning of a string literal, just know that that's what that is doing. It is kind of suppressing the need to escape special character sequences. You can just go ahead and use your backslashes kind of however you like. Without it, you would have to go through and then escape each of these backslashes here. So, okay, that's it for this video, a short little one on file output. I hope you found it useful.